Rectangle R is formed by joining the centers of two congruent tangent circles and then drawing radii perpendicular to a common external tangent as shown. If the perimeter of R is 60, what is its area? So let's label this. This is R for radius, and this side will be 2R, the same as that because it's a rectangle. So they're saying the perimeter is 60, so that basically means that 6R is 60. So that means R is 10. And then they want the area of that rectangle. Well, the area of the rectangle will be length times width. The length is 2R, and the width is R. 2R would be 20, R is 10, so therefore the area is 200. For what integer n greater than 0 is 100k squared times 100k squared equal to n squared times k to the power of 4 for all values of k? 100k squared times 100k squared is equal to n squared times k to the power of 4. So 100 squared times k squared, 100 squared times k squared, and then we have this stuff here. Okay, let's combine it. So we have 100 to the power of 4 times k to the power of 4 is equal to n squared times k to the power of 4. K to the power of 4's cancel, and therefore we're just left with n squared is equal to 100 to the power of 4, and therefore n would be the square root of that, which is 100 to the power of 2, which I believe is 10,000. At an annual high school parents' dance contest, the ages of the winners were the two smallest consecutive integers whose squares differ by more than 100. What is the least possible sum of the ages of these two parents? All right, so we have two consecutive integers, n and n plus 1. And then they have told me that the differences, so n plus 1 of the squares, so n plus 1 squared minus n squared, has to be greater than 100. All right, let's see what we get. Expanding this, we get n squared plus 2n plus 1 minus n squared greater than 100. So 2n plus 1 is greater than 100, and therefore 2n is greater than 99, n would be greater than 49.5. So if n is greater than 49.5, the smallest, because we're looking for the smallest, least, and therefore the smallest would be n equal to 50. And therefore, that's 50, and that one guy would be 51. And what are they asking for? The sum of the ages. Okay, so the sum would be 50 plus 51, which is 101. The number 1000 has 16 positive integral divisors. How many positive integral divisors does the number 3000 have? Okay, well, there's a, I don't know if you call it a trick, but it's a formula. If you have a number and you do its prime factorization, and it's p to the power of a and q to the power of b, the number of divisors would be a plus 1 times b plus 1. So let me give you an example. Actually, let's just use this as an example. So you take the number 1000, break it up into its prime factorization, which I believe is 2 to the power of 3 times 5 to the power of 3. So the number of divisors would be 3 plus 1 times 3 plus 1, which is 16. And they told you that, so that this formula obviously works. Now they're saying do the same thing for 3000. Okay, not a problem. I can do it for 3000. I think that prime factorization would be 2 to the power of 3, 3 to the power of 1, and then 5 to the power of 3. So using this formula now, it would be this guy plus 1, this plus 1, and this plus 1. And then so that's going to be 4 times 2 times 4, and that is 32. In the coordinate plane, any circle which passes through minus 2, 2, and 1, 4 cannot also pass through x, 2006. What is the value of x? So if we have a coordinate plane, let's just say we have minus 2, so this point, and then what is it, 1, 4? So 1, 4, let's say here. And we got some circle that goes through those 2 points. So something like that, right? They're saying well, let me just highlight those points. Those points disappeared. This was the point, and this was the point. And there's another point that it cannot pass through. Interesting. Okay. In the coordinate plane, any circle which passes through -2 and 1, 4 cannot also pass through x 2006. I'm thinking there's like so many possibilities, right? Well, one thing is for sure, that if you have a straight line, right? Let's draw a straight line. And that straight line kind of goes through those 2 points. Then if you had a third point somewhere on that line, somewhere, let's say here, it cannot be on the circle, right? Because 3 points on a straight line cannot be on a circle. If you have a circle and you draw a line, maximum 2 points on that line can also be on the circle. You cannot have 3 points on the line that would be on the circle. That's impossible. So that's the approach I think we'll use. So first we have to figure out the equation of the line, which shouldn't be a problem. Y is equal to mx plus b. M is the slope, so rise over run, that whole thing. So what's that? 4 minus 2, and then 1 minus 2. So that's going to be 6 over 3. 6 over 3, which is 2. And then that means I have y is equal to 2x plus b. And then 4 is equal to 2 times 1 plus b. B would be 2. So therefore the equation is 2x plus 2. That's the equation of this line here. So this point lies there, which was this one right here, 1, 4. And then this point lies there, which is that one. So if we have this one, it will be on the line, but it will not pass through the circle. So let's put that in. So the y value is 2006, 2x plus 2. So that means 2x is 2004. And then therefore x would be 1002. In a plane, 2 congruent squares share a common vertex but have no other points in common. Connect pairs of the remaining 6 vertices to get 3 parallel segments. If 2 of these segments have lengths 8 and 6, what are the possible lengths of the third segment? So here's the diagram, and as you can see, you got squares, and this is the one vertice that they have in common, I guess, share a common vertex. And then they then have these 3 parallel segments. So you've got this top line, this line, and then the bottom line. Yeah, those are the parallel segments. So we'll call them L1, L2, and L3. Yeah. And they're saying that 2 of them have the lengths 8 and 6, and they want you to figure out the other length. So for example, if L1 was 8 and L2 was 6, then L3 would be L1 minus L2, which is 8 minus 6, which would be 2. So that's one possibility. Or if we set L2 equal to 8 and L3 equal to 6, then L3, hold on, L2 is 8 and L3 is 6. L1 therefore would be L2 plus L3, which is 8 plus 6, which is 14. So those are the 2 possible values for the length of the third segment, 2 and 14.